All right. Good morning, good evening, or good night, depending on wherever around the world you are. My name is Alex, and it's my pleasure to welcome you yet again to a fantastic episode of Microsoft Learn Live TV on the Cosmos DB series. Today, I have here with me my good friend Marilag. Marilag, how are you doing?
Hello, not so bad. I'm doing good. Yeah, hi. I'm so excited to be here.
It's your first time, isn't it?
It is. So I'm so lucky to be next to you doing this. You've been
Don't
doing this
even
quite a
mention that.
lot on a Cosmos DB.
Don't even mention that. We're going to have a lot of
Yeah,
fun
so
today. Yeah, we're going to have a lot of
I
fun today,
know.
actually, covering our topic, which is
Of
going to be on
course.
querying the Azure Cosmos DB SQL API. It's a bit of a new topic actually, because this is a part of the series, right? And in the previous episodes, we have actually talked about things such as cross-point operations and configuring the API and configuring your storage accounts and thinking about data modeling and partitioning. But now we're kind of getting back to the fundamentals. We're getting back to the basics, writing a query in Cosmos DB because things are a bit tricky there. So again, my name is Alex. I'll be your host together with Marilag. Marilag, why don't you introduce yourself?
Hello, my name is Marilag Dimatulak, and I am an Azure MVP, and I also own a company that's based in Copenhagen. I'm in Denmark right now, and then also we have a office in the Philippines. I am originally from the Philippines, but I have been living in Scandinavia for far too long. So, and I haven't been home for 2.5 years, I guess. But I'm making sure that I'm going to go this year. So I'm also very active with the community. I'm the organizer of Azure User Group Denmark and Azure User Group Philippines, and I also am one of the co-founders of a not-for-profit organization called ulap.org. So basically, that's where all my time goes: company, work, and orgs.
You must have a
Yeah.
lot of time on your table because you're doing a lot, Marilag.
Well, we have calendars to
We do,
fill
we do.
boxes in.
Very nice. Everyone, make sure you follow Marilag on Twitter as well, because she's quite active there as well. You'll find her Twitter handle right next to her name in the dark blue box that you see right there. And my name is Alex. I'm going to be your host together with Marilag. My title, it's not really a title, it's more of a program. I'm an Azure MVP, also super passionate about data and Cosmos DB in particular. Have been working with Azure literally ever since it was a baby. Also part of the regional directors program, but fear not, I do not work for Microsoft. I did not take the blue pill. In fact, none of us MVPs or RDs are working with Microsoft, but nevertheless, we have been working around the Microsoft technologies for many years now. And here we are sharing our passion with you guys. And we do say hi to everyone watching us on Twitch, YouTube, Learn Live TV, or wherever other streaming media you're watching us from. We also have here a large group of people who have actually put a lot of effort to make these series even possible to begin with. And we do say hi to all the principal program managers and producers out there, but especially to our moderator today, which is going to be Chris Hyde, a fellow MVP of ours on the data platform award category. Hi, Chris. Make sure that you also say hi in the chat windows on the various streaming platforms that you're coming in from, and just tell us where you're from. We will be more than happy to know where people are watching us from. I'm sure there's somebody from Romania, just like myself, and I'm pretty sure there's somebody from the Philippines, right, Marilag?
Oh, I hope so. I don't know. Maybe if they like watching live in the middle of the night, then they're probably watching. But I'm sure they're going to be watching the recording. I'm promoting this series all over the world. So,
Definitely, because this is also going to be recorded and it's going to be available on the various platforms, especially YouTube, which is my favorite. I don't know which one's your favorite.
oh, yeah, also YouTube.
There we go. Okay. So this is going to be part of a series, as I've said. This is part of a series. This is already the ninth episode. Actually, we have had one in December. The first episode was on data modeling, and you can watch the recording if you want on YouTube. And then we have had 8 more episodes. This is actually the 8th one. We have 7 more episodes in 2022, ever since we started the year. And today, as I said previously, we're going to talk about querying the Azure Cosmos DB SQL API. I'm really excited about this one, aren't you?
Yeah, me too. Because it's a little bit more, like when you're getting dirty with the things, you're starting to do more programming and development, because I guess the previous years it's more the design thinking, the preliminaries. How do you make it, or how do you design your Cosmos DB account to be performant, and how do you model your data, as you mentioned? But now it's fun. Yeah, it's basic, it's fundamental, but we need to start from something, right? So I'm very excited about this topic as well.
Absolutely, because at the very first episodes, actually, we talked about the configuration of the SDK, the configuration of the code of the accounts, the configuration of the RUs. We defined what an RU is, and then we started to take the SDK up for a spin. We effectively configured a bunch of different operations like inserts and writes and deletes and whatnot. And we have learned how even data modeling, for instance, can tweak the RU consumption that we currently have and efficientize our operations. But when we think about data, at the end of the day, we're not only doing point operations. We're most likely going to do a query, which is effectively I think the simplest explanation of a query is just get me a bunch of data based on some filters, based on my business logic, right? And that's what we're going to talk about today. Now, there are going to be two episodes actually. This is going to be the first episode, mostly focusing on the fundamentals. And even though we do say fundamentals, there are going to be a few tips and tricks shared today as well, which many might not even be aware of. And then there's going to be a second episode next week on the more advanced topics and the more complex queries. Hey, Marilyn, do you know why we're doing this series in the first place?
Well, yes, of course. We want to get certified.
Spot on.
Yeah, so this exam measures your ability to accomplish following technical tasks. So again, about learning how to model data and how to really architect your implementation, learn about data distribution, and learn about how to really optimize your solution. So we need to measure these capabilities and abilities, and that's why we are doing this for you, so you can get like the end-to-end picture of how to really develop on Cosmos DB.
And there is indeed, as you have mentioned previously, there is a certification, the Microsoft Developer Specialty Certification. In all fairness, the exam last time I've checked last week was still in beta, which means that you can take the exam with a major discount, and you will get the reply based on your score once the exam gets out of the beta phase and is going to be G8. The reason behind that is that they might actually change some questions. They might pull some questions out of the actual exam based on the feedback that you're getting. So being part of beta not only means that you're getting a major discount, but you also get the ability of sharing your feedback and your knowledge based on some of these questions. Some of them might be confusing and whatnot, and that's also going to be in your own interest. Okay.
Yeah, I just to add, I just remember when I took the certification for developer, there are a lot of questions around Cosmos DB. So now it got its own certification path. So it's a really great way for developers who really want to focus on Cosmos DB to illustrate or their capability.
Yeah, absolutely. Couldn't agree more. I do want everyone to remember that this is going to be a live session, and therefore it should also be interactive. So make sure you say hi in the chat window. Make sure you join us in the chat at aka.ms/learnlivetv. Again, that's aka.ms/learnlivetv. And as soon as you have any questions, just feel free to ask them. Our moderators will actually cover them ASAP, and they're also going to have them forwarded to us, and we're going to pick the greatest questions in live and answer them. Okay, we do have a few learning objectives today, don't we, Marilag?
Yes, of course. So today we are going to learn how to create and execute a SQL query. And then we're going to learn how to best project this query results to our C# classes, and then also use built-in functions in a query. So we're not going to tackle all the built-in functions, but at least the ones that are very interesting.
And whilst we have mentioned that this is part of a series, and as you have already gotten accustomed to, we are actually following the Microsoft Learn modules, which are all about the preparation of one individual like yourself for the Microsoft Developer Specialty exam. In all fairness, we do have actually a bit of extra today, don't we? We're going to share some more insights and tips and tricks on date time conversion and null handling and undefined handling and whatnot, which I believe, at least, I don't know about you, but I believe at least is still part of the fundamentals, or should be at least, because it's all about how do you write a query.
Yeah, but we call it fundamentals. But the thing is, a lot of us are already very familiar with SQL statements. But that's kind of tricky when you're working with a new, with like if it's your first time working with Cosmos DB, right? So you're familiar with one thing, and then all of a sudden you realize, oh, this is a bit different for this product. So this is what we want to tackle here. What is kind of something that you're probably getting confused because you're used to another thing?
Yeah, absolutely. Good. Shall we get started?
Yes, let's do that.
Sweet. So Azure Cosmos DB SQL API, as you know, supports, well, the name kind of says it already, the structured query language, the SQL language. But in all fairness, in my opinion, this can also be a bit confusing because people have an expectation that that your NoSQL technology, namely Cosmos DB, is relational, which in all fairness, it is not, right? That's something that I definitely want to get out of the conversation, because it is not relational, right? It's still no relational. It's document based. It does not have to confine the particular relation or schema or whatnot. There's no table concept, no nothing like that. And even more so when you're writing a query, even though it looks like SQL, in all fairness, it's not. Like if your data platform is your father's old SQL server, yada yada, this is gonna resemble something out of that, only at a glimpse right at the beginning. But as you start to delve into the more complex queries, you'll see that even though they do call it SQL, it's not really, well, SQL as we know it, like anti-SQL based, right? So as we'll go through the module today, as we'll go through our lesson today, you'll actually learn how to create some of these queries, how to project your query results, how to use the built-in functions. And I say, well, let's not waste any more precious time and let's actually get to it. One thing which I believe is important as we delve into the topic is understanding the difference between the concept of a point read and the query. Most of our episodes in this series so far were all about data modeling, getting your data, and every single time we're pulling our data, we always had our identifier and also our partition key. And when you're writing a get of any sort, maybe you're using iterator or query iterator or whatnot, you're always just pulling a single item. That's what you're doing, because you have your identifier and you have your partition key. And that by itself is actually a very quick operation, isn't it?
Yes, that's correct.
In fairness, if you actually look at the latency that you're typically getting with a single point read operation, your latency is typically less than 10 milliseconds. In fact, there's even a marketing pitch. It's not really marketing pitch because that kind of gives it a negative connotation. In all fairness, it's all fair, which is that Cosmos DB has a single-digit millisecond latency, and this is what it refers to. There's going to be a point read operation, which is typically less than 10 milliseconds, irrelevant of which region you're picking, as long as you're querying your data, you're getting your data. Sorry, I was using the wrong verb. As long as you're getting your data for a point read operation from within the same region. But the reality is that when it comes to Cosmos DB, the way you extract your data is in two different ways. You can read your data doing a point read or a query. And most developers most developers will know that querying your data using Cosmos DB SQL querying language is an easy way to get to your data, right? But a lot of people don't realize that the point reads are actually a much more efficient way to read the data. The point read, as I've said previously, is like a key value lookup of a single item. So almost everything that we have covered so far in the series, as I've said, including the operations ran against models that we denormalize and so on and so forth with our data set, to optimize the RU consumption, they were all doing point read operations. But there are some major differences. Marilak, do you want to maybe go through the differences that we have between a point read and the query?
All right. So if you look at this table, so you already mentioned difference in the latency, and then also it is much cheaper in terms of the request unit. So if you do a point read latency, you can see that it's only costing you about 1 RU. But then if you do the normal query, then it's at least 2.3 RUs. Do you know why that is?
The RU, request units?
Yeah, no, I meant like why it takes more RUs to do a query
Oh,
instead of the point read.
I think that's a fantastic question, actually. So I would speculate that this has to do with the fact that when you're reading when we're thinking about the point read, we're also assuming that our document is going to be less than 1 kilobyte, right? Because the RU definition by design is that you're querying some data that is going to pull 1 kilobyte large, up to 1 kilobyte large document, and that's how you calculate your RU consumption. And you're getting your data rather than writing it, and not using a query. When you're writing a query, though, right, you don't specifically mention which partition you're querying data from, and you also have to traverse a bunch of indexes, which all by themselves have to be preserved somewhere. So effectively, I might be fully wrong, and I'm looking forward to your answer there. But I believe that you're going through some indexes first to retrieve where the data would reside at, and then you actually get your data, which is not even necessarily a single item. It can be multiple items. Is that correct?
Yeah, I think that could be right. And also, I think that if you use the query method, then it actually still goes to the query engine. So there's some processing behind the scene to be able to get to your data. Whereas if you do the point read, it's just going directly, it's just looking up this key value pair. And obviously, because with the point read, you're specifying the partition key, then sort of behind the scene, like down the network and the nodes, it just goes straight to the nodes where the partition is. Whereas with the query, I guess it's parsing the query first, finding out if in that query you have the partition key definition, and then translating that and finding the index as you mentioned. So yeah, so it's just a little bit more expensive, but not very obvious. So it's good to know that we have this capability using the SDK.
Yeah,
For SQL
absolutely.
API.
Absolutely.
Yeah, so there's another difference. So when you also do the point read, it automatically returns just one item, versus if you do the query, it actually returns infinite. So if the result size is large, then it can also be paged. Practically, if you do this via code, for example, later on you will see that in the demo, that when you issue the query, you're actually using the query iterator, and then it's just like you expect to get a collection from that, and then you again iterate from the collection to get that one item that you are looking for. Or if you're using link queue, you can do first or default or something like that, which is very unnecessary. But if you do the point read, then you just get one right away. So that's another difference, right? And then we already talked a little bit about the partition key. Of course, for point read, this is absolutely mandatory. But for query, again, this is optional. But that can be very expensive, as we all know. If you don't put the partition key in your query, then it's going to do a cross partition just to find that particular
But
item.
I think it would be useful to explain again why it is recommended to have a partition key even when you're writing a query, right? Because the mindset about the query to begin with is we don't know our data, right? Because otherwise we would just give it its own address, so to say, where the address is nothing else but the partition key and the identifier. When you run a query, you don't know an address of sorts, right? You don't have an ID, you don't have a partition key necessarily. Why is it recommended to have a partition key included in the query?
Again, to optimize, right? So first of all, when you do partition key, what happens is that Cosmos DB knows in which partition or which node under the hood it's gonna point you to, so it doesn't have to look at all the different nodes where the data is residing just to find out what you're looking for. Of course it can, but it's just much more expensive. That's why it's recommended. It's not required, because it can still find that data across all the nodes that's running behind where the data is stored. But with partition key, it knows, or Cosmos DB knows exactly where to find it.
So put differently,
That's
if
one
our
thing.
data is literally spread across multiple physical partitions this time around, non-logical ones, we're going to have CPU burned, right, and IO done on every single partition just to retrieve if there is a result within that partition, right? And then from all of these physical partitions, there's going to be, well, I would make an analogy of a union of sorts, where all the data set returned is going to be returned into a single result back. And obviously it's going to take more time, and therefore it's going to consume more RU, because it also consumes more CPU across every single physical partition.
Exactly. So everything has a cost.
It definitely does. What I found interesting was, as I was working with some of my customers who were eager to get started with Cosmos DB and not necessarily following the right path on implementing Cosmos DB, is that they were doing a lot of queries even when they were supposed to do a simple cross-point operation. Maybe they were unaware of the impact of doing a query versus doing a point read operation, or maybe they were just missing out. I'm not entirely sure what the case was with each of these customers, but the reality is that in many of the cases, changing from writing a simple query to a point read operation is just almost a snap of the fingers, and I kid you not. Like most read heavy workloads would use a combination of both read point operations and SQL query operations. And if you just need to read a single item and you know it's going to be a single item because of your business logic, because of your data modeling techniques and whatnot, obviously point read operations going to be much cheaper, much more efficient, much faster, very small latency. So and the reason behind it again is that they read the data directly. They don't require the querying engine, which is going to increase the RU charge to begin with.
Yeah. And good thing that you mentioned that it is super easy. I actually had one experience with one project that we were seeing some performance bottlenecks and we were trying to optimize. So I took a look at how the queries were written and actually found some of these queries that can be converted to point read. And so when we did that and measured, of course, the latency and the improvement and also the RU, so we really gained a lot. So recommend it to everyone. If you are not doing that yet, now is the time.
It's a good time to do so. Now let's imagine this fictional scenario where we have our typical multi-impressive corporation called Contoso. This time around, let's imagine they have a large orders container that has customers' orders data. Now, each item in the orders container would represent a separate customer's order, and you can normally just identify that information by looking into the identifier of the order. So the partition key of an order would contain things such as the customer identifier. So what you see here is an example item of the orders container, where the order, as one might tell, is just an object with an identifier, as I've said previously, a customer identifier, and a bunch of order details which are within an array. Now, the application runs a query like this one right here, select from C stands for, well, let's say container, where the order identifier is and the customer identifier is whatever other value. So this query will actually cost a little under 3 RUs when it is executed. But because the query has an equality filter on the customer identifier, which one might speculate could be our partition key, and the query is actually an in-partition query. Now, while this query is quite efficient, it could also be written as a point read operation. And the way you do that, at least in C#, is that you would instantiate your client first and foremost, and then you'd pick your container out of that. And once you have your container up and running, you would simply say on the container, read an item async. We're going to pull. This is a generic method. So we're going to pull an order object where the identifier of the document we're querying or we're grabbing is going to be order 0123, and the partition key is going to be whatever partition key we initialize over here. And this effectively now turns a query into a point read operation, which can literally significantly reduce the RU. Generally speaking, I don't know about you, but generally speaking, with some of my customers who are doing all of these very frequent single document read operations, but running a query, when we get, well, cranking, honestly, we end up having savings of up to 66%, which is quite impressive, especially because these are typically a lot of operations that they're doing, and they're not realizing they're spending RUs just because they're running a query rather than running a point read operation. Now, one thing, you can only do a point read operation if you have both the identifier and the partition key of an item. And the ID and the partition key combination must also be globally unique for items within a container, right? So developers know to take great care in selecting good partition key, and this is going to be a very important, critical choice really for the Cosmos container. But it is not widely known that assigning meaningful values to the ID property, like literally ID, is going to be required for doing point read operations. And I believe this is also one of the reasons for at least some of my customers have failed in actually implementing point read operations. Because if you don't call, let's say, your order if your order object does not have a property called ID, but you rather call it order ID, then the SDK and Cosmos is automatically going to enforce a property called ID on you. So when you're reading the data, you no longer know the unique identifier of the document. You just know something that is meaningful for your application, for your business logic, which means that you cannot do a point read operation, but rather you have to write a query. And now you're missing out on the RU optimization that you could get out of a point read operation. So again, if you have an object, which because you were taught to typically name your properties meaningful in C# and even in SQL back in the relational days, you'd have your order ID within an order table or the order details table, for instance. You want to make sure that in the JSON document that you're saving within Cosmos DB, the property is going to be called ID. It has to be meaningful, because otherwise you cannot do a point read operation.
I actually have a question on that, just to clarify. So let's say I did not define ID as my unique identifier for that particular object. Let's say the order ID. So I didn't know about it, and then so the ID was auto-generated. But let's have an application, a simple web page that gets a list of all, let's say, orders, and then it returns the ID there. And then I clicked on the order, and then now I know the auto-generated ID, the value for that. Can I still do a point read?
Yeah, you can still do a point read because you'd know the automatically generated value out of that for sure. Yeah.
But by that time, that requires that you have already read all the data beforehand to get that value. But if somebody is just typing an order ID, then that won't work.
I mean, the order might not be the greatest case, because sometimes you don't even want your order identifiers to be meaningful, right? And the reason for I'm saying that is that if you're missing out on having an ID property, one is going to be automatically given to you, and it's going to be a random value, unique random value within the container, within the combination of the partition key and the identifier, right? So it is actually a good fit for orders. But if you have something that is meaningful, must be descriptive, must be maybe auto-incremented of sorts, not calling that thing ID requires that you do some sort of another operation, probably a query, to retrieve the identifier that you could do a point read operation with, and you've already wasted some time. So if we would speculate the scenario for the order ID again, imagine you're sending an invoice, and the number of the invoice matches the number of the order, for instance, and now you want to bring up the order details of whatever you see on the invoice, 1, 2, 3, 4. You'd have to first query what is the identifier of 1, 2, 3, 4, order ID equals 1, 2, 3, 4, and you get another ID, and so that now you can do the operation, which is obviously nonsense. You're not going to do that, because otherwise it would be pointless to have the query operation to begin with. You do a query where you have an index on the order identifier, but now it means that you're spending more RUs rather than doing a point read operation. Does that answer the question?
Yeah, absolutely.
I hope that everyone got a sense where or why point read operations are so important. And simply for the fact that we're introducing a new topic such as querying, we're not ditching this point read operations that we have been talking about for so long, at least in this series, because they're still going to be critical when it comes to, well, getting the best performance out of your containers. So with that being said, I think it's actually a good time to introduce the querying language, isn't it?
Yeah.
Let's do that.
So
go ahead.
Yeah, so with the Cosmos DB SQL API, use an already very popular structured query language syntax to perform queries over semi-structured data. We talked about that earlier. But if you're used to other database platforms like MySQL or SQL, you may already have some of the tools necessary to write queries in Cosmos DB SQL API. And I think that's one of the most interesting things when I just started with Cosmos DB in the beginning, because I already know this syntax. So it's a matter of sort of matching what you know with what you don't know yet about Cosmos DB. But let's start with what we already know, right? So we for this module we are gonna focus on a fictional container of products. With, you can see the structure here. It's very common. You have the, we just talked about the ID, which is your unique identifier, and your category ID, which is your partition key, and a bunch of other properties. So if we uh, look at the document in Cosmos DB for this particular structure, then the JSON document would look something like representing that property with all its fields in the document.
Yeah, absolutely. And in all fairness, for those who are in the audience and who attended our other episodes, you've probably already get a bit of a deja vu moment, because it's always this products container with a bunch of attributes along the lines of ID, category name, SKU description, price tags, and whatnot. At least on this slide right here, we have an example of how a JSON like that would look like. But obviously, it's probably out of the anyone's interest to go through a JSON like that. But just to emphasize a bit, this is going to be the structure of documents that we're going to work with from this point onward. So if we are about to write our first query using the SQL-like language, right, we're going to start with the most basic SQL-like language. Probably the easiest one is going to start with the select, because every single query should have, because it's SQL, should have a few essential components: the select keyword, followed by the list of fields that we're trying to query, it effectively retrieve, or even an asterisk, which everyone knows is just effectively saying, yeah, just get me everything, all the attributes that you're aware of, followed by the from keyword, which is going to indicate which container, which is our data source, which container are we actually querying, and then followed by potentially a list of optional joins and filters, predicates, and whatnot. So I would imagine that the simplest kind of query that we could ever write is just select star from products. And I'm sure there's going to be somebody in the chat window actually contradicting me and tell me that there's an even simpler query, probably, right? Which has almost no value whatsoever or whatnot. But nonetheless, another query that you could write would be the one that you see in the second box right here, where you're running select products ID, products name, products price, products category name from products, right? And we can tell here that products is actually used even as an alias almost of sorts, even though it's not an alias, it's simply the name of the container that we're querying. And then we're just saying from that container, we want to pull the ID, the name, the price, the category name, and whatnot. But we could also selectively emphasize an alias for products so that we don't fat finger our command, because you can tell we have a lot of keyboard key strikes to do. So we just simply use an alias of P, and then P.name, P.price would be the command that we would write. This is, if you think of it, actually, in Cosmos DB, one interesting caveat is that it doesn't matter what name is actually used for the data source, because what you're doing is that you're referencing the data source as you're writing the query, right? So you're effectively saying, hey, I want to query this container, and yada yada, here's the query. But I've already specified which container I'm querying. So that from almost becomes, well, it doesn't matter.
Unnecessary.
Yeah, it's almost unnecessary. But if it wouldn't be there, it would not follow the SQL structure. So it's mostly, in my opinion, I might be wrong on this one, so take this with a grain of salt, but I believe that the reason for having the from keyword there to begin with is just to make it simpler for people to relate to the querying language, because otherwise it's fully unnecessary, because the data source is already mentioned.
Exactly, but that's actually one thing that is very fun, that you can name this whatever you want. But maybe if you are new to Cosmos DB, sometimes you get thrown off. It's like, why am I not using select asterisk from my container name? Or all the examples that I see is C. But you gave a very good explanation, Alex. So I was very, very curious in the beginning about that as well.
Awesome. And yes, you can pretty much use any word or phrase you'd like in your developer code. I'm not even going to try to read these out loud, but you can already get the idea. And you can obviously use some aliases, and you can use aliases to make it simpler to refer to the data source, or simply refer to some of the tables that you might be. I mean, not tables, but structures that you might be joining with. You were going to cover that in a separate module. You can also filter out queries using the where keyword, as you might expect. So if you have a predicate such as this one right here, where p.price greater or equal than 50 and p.price lower or equal than 100, as you might expect, this is going to return products where the price is in between 50, I would imagine, US dollars and 100 US dollars, including. So your typical from where select structure is mostly going to be the same. And I think that's enough of an introduction on the querying syntax, because there are some special things about the way the SQL API works. So what about actually introducing them? How do you feel about them?
All right. So first, let's look at, projecting query results. This is probably one of my, favorite in this fundamental query topic. So, when we are developing applications, especially like, let's say you're a C# developer, because that's what we're using right now. So when things get very complex with our application, the first thing that happens is that our classes becomes more complex, our models become bigger, and it's also evolving over time. So maybe your structure or your model changes, but that's not exactly the same in what's happening with your database. So there's a lot of effort that's being put into kind of mapping what the shape of your persisted data into your application classes or your application objects. And if you have been working with relational databases before, you probably have experienced some of this pain of migrating your schema in your database just so you match your definition in your application. It takes a lot of effort. So that's when ORM comes in. Correct. So every time there's one slight change in your class, for example, you add a field, you have to run some migration script so that it reflects on your database. So it's a little bit different if you've been working with NoSQL database. It's a little bit different precisely because it's a schemaless. So that means the documents that you store in your container doesn't always look the same. And the good thing is it's very easy to match what you have persisted onto your classes. So when you look back to the JSON document that we saw a product with a bunch of fields. We saw a list of tags, if you remember that. You can match that directly or project that directly to an existing class, which has these properties, and then maybe another property called list of tags. You don't need extra work to sort of deserialize what's stored in your Cosmos DB into your classes. But sometimes you need to kind of tweak the result of your query in JSON, because if it's not exactly the same as your data model, let's say your class has a different field name, but that's not the same in the database, then you can do some fun stuff in your query to match that. You've mentioned already, using alias, so that you can also use aliases on your property list. But there's another way of doing it. For example, if you have complex types, like you have objects in your classes, then you can also modify your query to be able to project that. Like, for example, you can modify your query to show or create a JSON object within your select list so that it will match your data model. Maybe you can continue on that, Alex, and show how that works.
Yeah, absolutely. So previously, I showed you a very simple select where we ran a query where we were retrieving products where the price was in between 50 and 100. And following up your example here, we might have our classes named differently. And I just want to add to that. I just hate the days when we do refactoring in our classes, because it just is such a burden to change everything in SQL
Yes.
servers, the sort of procedures, the data access libraries, the layers. Oh my God, I would so not be in the office during those days. But in all fairness, in Cosmos, it actually gets quite simple. So here's an example. We have a JSON document which contains or is a result effectively of a product where the price is between 50 and 100. And this is just a bottom bracket, for instance, right? And within the category of components, bottom brackets. Now, if our class in C# would look like this, and you see the rectangle with the code snippet on the right-hand side of the slide, where we have a name, a category, and a scanner data, right? The scanner data contains the price. We can already tell that there's a bit of a hodgepodge here, because our JSON document returns a property called category name, whereas the property in C# is simply called category. So we have to fix that. Now, one option many people relate to or get back to is that they use a JSON, namespace based on JSON serializer or Newton software, whatnot, where they change the property name of the JSON object that would be serialized or deserialized respectively. But it's not necessarily what you would have to do or want to do in many other cases. Also, that would not help if you have a more complex object as a property where you have a scanner data object within, or this is a class nested within the product advertisements class, where the price is a property of that class instead, right? So it's not a literal within the product advertisements class. So we have to change the way we return the data from Cosmos DB to actually match our class. And the question is, how do we do that? Now, one easy way to fix this is by actually applying a change where we're simply changing the alias within our query. And in my opinion, at least, this is much simpler than actually changing the class definition within the data access library, for instance. We would simply run the query where it would say select P is the alias for products name and category name, but we also use an alias for the category name attribute so that it's returned as category instead, which means that the JSON object that would be returned would no longer have a category name property, but a category name instead. That would match our C# class. So this would make it simpler to deserialize the object. Now, the second change we have to apply here is one where the price property or attribute returned from the document now becomes a nested object within the scanner data. So how do we do that? Well, interestingly, in the select, if you actually encapsulate the select with curly brackets and you simply say price colon p.price, you're effectively creating a JSON object that is returned as a property within the document returned as a JSON object from our query, which means that the actual object that we're returning here would literally match the class which is nested within the product's advertisements class right here. So by applying a super simple change within our query, we effectively tweaked the way that the JSON document would be returned from our query, and we also tweaked or simplified the deserialization process into our object. How do you find that, Marilag?
I think that's very powerful. That made me really, really happy discovering that. So, yeah.
Another interesting trick is that sometimes you want to shape your query results to drill down into specific properties. And two keywords are actually useful for this. But first, let's consider a scenario where you would like to find all the category names in the container. And you could use a query like this one, where you're saying select category name from products. And this would supposedly return the category name for every single item that you have inside your products container. So as you might expect, this is going to return a JSON document. But unfortunately, because inevitably, you're going to have multiple products of the same category, you're going to see the category returned multiple times. So this is going to be annoying, at least if you're trying to, for instance, say render a facet on an e-commerce website, like the category names that you could filter on. Or if you want to use these categories for maybe a back office application and use the existing categories rather than create a new one, this is not going to be helpful. So the simplest thing that you can do is you simply add the distinct keyword that would only return the unique values in the result set. So the only change I did here is, simply specify distinct, and then my query becomes select distinct category name from products P. And as long as the category was already within the result set as it was computed, it's not going to be duplicated anymore. But let's also consider another interesting scenario. If your .NET developers wanted to, let's say, consume this list of category names, they would need to create a wrapper class to consume the list. I don't know about you, but I just got rid of all of those classes that I had to write for my data access libraries just to match one another query that returns some sort of an object. I mean, typically my projects have a models folder, which is just filled with classes of various objects that would be returned. And I kind of got rid of that. I'm just tired of that. So here we have just one of those examples where we have a category reader class and the category name property within that. So this extra step that you typically do with this extra class is almost needless. It's just boilerplate code, right? That's what you're doing. And therefore, it is to an extent unnecessary. And it can become quickly cumbersome, as you will need to do this multiple times, over and over and over again, for every single type of an object, for every single container, for every single report that you were going to retrieve. But if you have a query that actually returns an object with only a single property, you can use another keyword, which is value, which is going to flatten the results to an array of a simple type. So actually, by running the query that you see in the bottom part of the slide, select distinct value, category name from products, what you're going to get back is a list of categories. So I don't even have to create a special plain old CLR object with my own complex class, which is obviously not complex, just to maintain a single property called category name. I don't need that. Right? It's a single property within an array that I need to return. So let's just use that one extra keyword, which is values, and let's just read this darn value, and that's it.
Right. So you're saying that it effectively flattens an object, which is typical in JSON. If there's only one property, then it just flattens it into an array or array of strings.
Spot on. I couldn't have said it any better. It took me 10 minutes to explain it. You just did it in one. Great job.
I just flattened it.
You just flattened it. Great job. Now, I also believe that it's quite interesting when it comes to querying arrays in Cosmos DB, because arrays is a much more special thing to Cosmos. Remember, in Cosmos, you're actually storing documents. These documents are represented as JSON objects. A JSON can have a property that is of type of another JSON object, which can contain arrays and whatnot. In your typical relational database structure, you don't have that. You would have tables with 2 dimensions or multiple dimensions, but you don't have arrays typically, unless you have a string that is converted as a serialization format, maybe an XML or JSON as a single attribute, but it would be a completely different conversation. So for this one right here, let's assume that we have a Cosmos container that has, for instance, like a shopping list that's modeled as JSON documents. And for this one, we're going to have a bunch of objects where we have an identifier and then a city and a bunch of gifts that the identifier is going to toss around for people. So if you, for instance, want to retrieve a single item within an array, one thing that you could be doing, and I think this is quite interesting and quite lovely, is that you can simply say, hey, I just want to retrieve from my container something where the gifts, and then you use an index, is whatever value. So this query would be super, super, super simple to understand. But here's the deal. The query would actually find all the shopping lists that have a recipient named, in this case, Alice, where the position, where this is the first position within the gifts array. And even though the query is very simple to understand and is inexpensive to run, filtering based on a specific array element isn't enough for many scenarios, for most scenarios, really. So Azure Cosmos DB actually provides support for iterating over arrays by using the in keyword in the from source. And this is, again, best illustrated, in my opinion, with an example. So the query you have here will actually return the data from the gifts array from all the items in the container. So let's take a couple of steps back. Let's imagine that we have the t in t.gifts, by the way, is just arbitrary. So don't even bother about that. We could have used any letter or word except for C, because C is used for referencing the item from the container. But here we have T used for referencing the arrays. So what we're doing is we're saying retrieve all the data from the container where we're looking into the gifts property of that array. Let me take you a couple of steps back to the JSON. Let me zoom in real quick. So this is a JSON object that I would have a single document that I would have within my container. Many different documents would contain this. And then we have an array, which is the property value of my document. And I just want to retrieve this part right here, right? So that's what I'm doing with my query. I'm retrieving only the gifts effectively. That's what my in keyword would effectively do. But let's take it a couple of steps further. If we ever say that I want to retrieve all the elements, all the gifts where the recipient is called Alice, I would simply say select from C the item, the container, right? In gifts, which is the property of the array type, where the recipient is Alice, which is a major difference from the way I did it previously, where I was iterating where only the first position of the recipient would be Alice. And you probably can tell where the problem with this query relies at. The recipient might not be on the first position, might be on the second position, the third position, and then this query effectively fails. By definition, a JSON array is not meant to be sorted, right? It's the processing that you did in memory of the object after you deserialize it in order if you want to sort it or not. So there is no expectation that whatever element that you're looking at is going to be on the first position or not. So if you look at our JSON again, you can tell here that Marillac, Jason, Alice, they might be in whatever position you'd want to have them. So this query effectively here is flawed by design. You don't want to do that. But simply by using the in keyword, not only did you fix this, but now you've opted to iterate over an array by using the in keyword in the from source, right? Which wouldn't be possible any other way. In my opinion, this is just lovely again.
Right, I agree.
Shall we maybe also talk about implementing type checking in queries?
Yes, let's do that. So, one of the Azure Cosmos DB SQL's advantages as a data store, it's very flexible to store data with structures, varying structures and shape. You can even have different documents within the same container that is completely different shapes, right? But then you start to think as a developer. So now when I was used to just dealing with tables before, I know exactly the shape or the result of those tables because there is schema. And it's not the same with Cosmos DB. So when I issue a query result, let's say just for the product, a query just for the products, let's say maybe some of the products have a property called tags, and then some of products don't have that property at all defined. So it kind of becomes the responsibility of the developer to check some of these data types from your end. Obviously, you can do that on your application code, but you can, of course, do that even better or more efficient using your query language in Cosmos DB. So there are a bunch of built-in functions for basic time checking. So let's go through the first one. So let's say, I mentioned that maybe you are saving products, and it's well known that all products have tags in the beginning. So you assume all products have tags, but then maybe something has changed in your requirement, or it's a different scenario where there are products that tags are not required. So it's just simply not there, but it's still in the same container. And then you wanted to load these items together, but then first you need a logic to check whether this tag is existing or not. So you have a built-in function in Cosmos DB called isDefine. So isDefine, you use it this way. If you look at your SQL statement, select isDefine, and then you pass the name of the property that you are checking, and then give it an alias, tags exist, and then it will return true or false whether this tag or this property is defined. It's very, very useful. So one of the scenarios, for example, like I said, if your model has deviate maybe because it has evolved, then you can make this logic so that you avoid errors down the line and do not just assume that tags exist and maybe do something. If it's an array, you start iterating through an array to a property that does not exist. So is defined will give you this leverage. So that is one of the function. And then the next thing that we can use is also the null. Later on, I think Alex can explain to us, this is going to be fun, what is the difference between null and undefined. But just now for the specific query, you can also just add that property tags and then explicitly assign a value to it that's called null. And sometimes this can happen. Sometimes you set, let's say when you model your data in C# and then just pass that to the Cosmos DB SQL API without setting any value. That property already exists but doesn't have a value, and then it will automatically be saved in your document with a null value. So if that property exists on your class without a value, it will be null. So if it's set explicitly as null, then you can use the function isNull to check whether, the value is null. There are two ways actually. So you can use the built-in function isNull to check this, and it will return true or false. But at the same time, you can actually use the basic SQL query where you can just equate, like for example, C tags is equals to null. So that is also the same. And you can, of course, if these values, let's say tags, is either undefined or null, if you, for example, have to evaluate an expression, let's say select asterisk where tags is equals to something, and tags property does not exist, is undefined, or is there but is set to null, then the query will not return these items. So the query will not, if you do a filter in the query will not return anything that is, of course, if the value is false or the value is null or the value is undefined. So yeah, so those are some of the very useful type checking function. And we have something else also. Now you've started with the array, Alex. So let's
Yeah,
look at the
absolutely.
other.
There are going to be cases in which you want to, for example, verify that a given attribute is an array. And therefore, you could use this built-in type checking function, which is called isArray, which is going to effectively check if a given attribute is of a type of array. And the reason for that, or the explanation for that, is that sometimes you're going to have, in Cosmos DB, as you start filling in data in your containers, they don't have to have the same schema, right? It's NoSQL. And sometimes, regretfully, because we do refactoring and whatnot, you're going to have items such as tags, which can either be an array of multiple strings, each string representing a single tag, or it might be a single value, a literal, of type string, containing all the tags as comma separated. Obviously, the implementation that you have to do must be different when you run your queries, for instance, get me all objects, where I'm looping through the arrays as we have seen previously as I was working with the examples for working with arrays. And if, let's say, if my tags property of my document is an array, then I want to do a particular where predicate. But if it is not an array, then I would want to do a different where predicate. For instance, if it is a single string with a comma separated values of list of tags, then I would probably want to use a keyword such as contains. Does the string contain the tag? Otherwise, if it is a array, like a proper JSON array, then I would want to use a different keyword that actually loops through the actual objects I have within the JSON array. Hopefully this makes sense. It can be a bit confusing sometimes if you don't try to picture the various types of schemas that you have for your documents. But regretfully, it happens more often than not when you have that. For instance, we can also kind of think of this other situation where different data stores persist pricing information inconsistently. Some of them persisting pricing information using string data, quite often happens a lot. whilst others may contain the pricing information as a number. So the built-in function here, similarly to the isArray function that I've showed you previously, here is isNumber, and this could be used in a where expression for our queries. For instance, the first query could look into all the products, retrieving the price and the price with tax if the price is a number. If it were a string, this operation right here, we're trying to multiply the price by 1.25 would fail because you cannot multiply a string by 1.25, of course. So we want to make sure that the price is actually a number. And of course, this would rule out, it would filter out any of the products that are within the products container, any documents that are within the products container where the price is not a number. But for those, we'd have to write a different query and would have to treat that separately. In the second example here, we're effectively using the isString function, which is going to see if our price is a string and not apply any formatting to it whatsoever. And there are other built-in functions as well. There is an isObject, there is an isBoolean function, and I'm sure I'm missing some of these out as well. Hey, Marilyn, do you want to show us how you can use the built-in functions maybe?
Yeah, so on top of these very useful type checking functions, we also have the built-in functions that is very handy for us that can do some of the string manipulation and such. So we're not there are a bunch, so we're just covering some of the basics here. Like for example, if you want to put two properties together and then create a new string, I think many of us are familiar with the concat. So you can use this built-in function to concat, for example, property P name and then add a pipe and then the category name. So the syntax is here. You just pass the property separated by a comma. And then if it's a literal, then you can just enclose that with apostrophes. And then you can also, of course, use the lower built-in function if you want to convert your string into all lowercase. So for example, if you have this property school and then you're not quite sure whether it's lowercase or uppercase or kebab case or whatever case there's a snake case, and then you need to do some equality later on, then you can use the lower function. And then we also have several built-in functions for getting date, for example. So you can use this get current date time to get the current date time from your database, and then use that as a filter. For example, here we're trying to get all the list of products where retirement date is equals to get current date time, or the current date. So these are all very simple but very, very useful built-in functions. And this is not a comprehensive list of built-in functions for Cosmos DB query language, but then you can find a lot of this in the documentation as well.
Absolutely.
So now we go to the exciting part of functions for date and time. Alex.
Yeah, I really think this is exciting because the way you handle date and time in Cosmos DB is a bit, I wouldn't necessarily say tricky, but it has its own implementation. It has its own details, which are definitely different than you normally have them in any other typical data platform. One thing for people to remember is that there are two ways in which you can work with date and time or date time system functions. The typical recommended way is to use the ISO 8601 UTC standard. But alternatively, you could also use an epoch value to represent time as number in either milliseconds or 100 nanosecond ticks. Most of the examples that we're going to show you is going to use the ISO format, but it's also important to remember that you must be consistent when you do, for instance, comparisons. You cannot compare the ISO 8601 standard to an epoch value. There is actually a way, if you use a built-in function date time to timestamp or datetime to ticks, then you can convert them from one to the other. But this is going to incur additional compute power. And in my opinion, it doesn't make sense. If you just become consistent across with all the various comparisons that you need to do, you should be good to go. So if you, for instance, want to compare datetime strings, Azure Cosmos DB stores date and time as regular strings. There's no special storage format for date and time values. So comparing date and time strings, both equality and range comparisons between date and time values, they're all going to be supported. And since the date and time strings are going to be treated as ordinary strings by the querying engine, the date and time strings must have a consistent precision and also a valid equality comparison. The query that we have here is effectively just comparing two different date and times, and it's returning the result as a Boolean value where we also applied an alias of comparison result. But you could do other things as well. Marilag, do you want to cover maybe the datetime part function?
Yeah, so if like you want to calculate the current month, that's very common. So you can also use this function called datetime part, and where you pass your date and then the m, which stands for month, and then give it as an alias as month value, and then you get the number of the month. And then there's also a way to build time, actually, to build date time using the date time from parts, wherein you pass, for example, for this one, you pass your year and your day and your month and your time, your second, your hour, in whatever precision that you needed, as long as it's based, of course, on the ISO. And then actually give it an alias, like in this one, date time, and then you get your date from these different parts. So it's very useful for building your dates. So there is also another function, if you are not aware. So all the documents that are created in Cosmos DB is automatically timestamped. So you have a property in Cosmos DB document that's called underscore TS. And this underscore TS is always updated whenever you update that particular document. So this one is currently in an epoch. And then you can use this timestamp to date time function in order to convert this timestamp, which is an epoch, into a date time in ISO format, like for this one. Like I can show you in the SQL, you just pass in this case, you get the first item, and then you call the function, and then pass the timestamp property, and then you get the date. Yes. Do you want to talk about
the definitely. If you need to convert a datetime value, because you see it's an UTC-based standard, and sometimes you don't want to work with UTC because it might not be your time zone. You can obviously convert it to your local time zone, and you can do this using the conversion function, which is called datetime add. Typically, you can simply specify what exactly you're adding. In this case right here, in the upper part of the slide deck, we have a sample where we're calling datetime add, and we're adding 330 minutes to a given date and time. And then we're actually using an alias, and we're saying this is going to be your India standard time. And this is useful again because in this case, it allows me to add 5 hours and 30 minutes, and therefore convert whatever daytime I would have here to any other daytime format, to any other time zone. But in all fairness, I could choose not to add minutes, but hours maybe, or seconds, or years, or months, or you name it, whatever works for you best.
All right. So now we have learned all these different ways of querying our data in Cosmos DB. How does this look in code? How do we actually use this? For example, if you're building a C# based application, how do you execute these queries using the SDK? So Azure Cosmos DB has its SDK, which contains a couple of different classes and libraries that you can use to be able to connect to Cosmos DB, and then connect to your particular database and get your container, and then issue your queries and other operations. I think if you've been watching the other shows and sessions, maybe you've learned how to use the SDK to be able to create items or delete items or update items. But now we are going to try to look at how to use the SDK to run our queries.
Let's do that.
So we can start with a very straightforward SQL statements. So how does that it actually looks? So in C sharp, we have mentioned several times that you can define your POCOs like this one, and then in your using the SDK, you can define a query definition variable and then pass your SQL statements as a string. So you can also assign this SQL statement to a string variable and then pass that string variable to your query definition. It's going to be the same. And then there are a couple of methods that you can use from the SDK, is particularly for your container object. You can see also later in the demo, I can show you what you need to instantiate before you get to this part. But so once that you already have the connectivity to your account and then that you have created and connected to your container, then you can use this method called get item query iterator. So basically this will issue your query to Azure Cosmos DB using the SDK, and you can iterate on each of the item or the result sets. And this is a generic function, so that means you can pass the type that you are expecting, which I think also we can delve a little bit deeper. But to how to, you can use several types and how to use generics for this particular particular method. But for this one, we're just using products. You can actually use anonymous types as well, but that's not part of the session. But you can find a lot of guidelines on how to do that. But for this one, so we can iterate on the result set of the query, and then very easy as that. You can just do your your logic.
Maybe it is a good time to actually look at some code, Marilag.
All right, then so let me share my screen. Good. So if you are going through the Learn module for this one, you can find the exercise for this module. And in that way, you can start the lab, and the lab will give you a VM and then access to a free Cosmos DB. And then the VM also has VS Code already installed. And then there is a tutorial there for cloning the source code that we are going to use for this exercise. And actually the source code, you can find that in GitHub. So you have a bunch of all this sample code here that you can use for this particular module. We are using the number 09 execute query SDK. And so you can clone this one. And then if you're using the laboratory, you can create an instance of the Cosmos DB account in the Azure portal for free. But if you're not using the lab, you can also just run this on your own machine, and you can create your own Cosmos DB account like I did. And for training, you can use the free tier, so you don't have to pay anything. So I did that already ahead of time. So I already created my Cosmos DB account here. And there's also a fantastic tool for seeding your database called Cosmic Works. So if you install this Cosmic Works tool, then you can run and run some tools to be able to seed this particular data. In this case, I already created a database called Cosmic Works, and then we have our container here called products, and then a bunch of items that we can work with in the query. So I already also cloned the code. And so the code is very simple. You can find the class here, but for the product, and then this is our script class that we can use to call the SDK. So the first thing that you want to do is that when you have created your Cosmos DB account, here you need to find your keys and the URI of your account, because you're going to be needing that on your code to connect. So you put that as your endpoint here, and then you copy and paste the key for this one. I normally wouldn't do this in code. Of course, it has to be very, very secured, but just for fun, we're going to do it like this. So the SDK provides you some options here for, to control how you're going to connect to your account. And you're going to have a client. And then also you can create an instance of your database, and then also an instance of your container. And from there, under the container, you have all the methods that you need to run these queries. So let's try to run the very first simple query. So you can create a string with your simple query here, and then create an instance of the query definition. And you want to iterate to the result of this query later on. So you have a for each, and this is asynchronous. So you have to use a wait, and then you can call the container that get item query iterator, and use the product as your this is signaling Cosmos DB, hey, if I run this query, please deserialize this result, the JSON result, which is typically a string, into this class and object. So one thing that I would like to note with this is that, for example, in your document, you have a bunch of other properties on your document that is not defined in your class, in your product class. So that's just going to be ignored by the SDK. At the same time, if you have defined other properties in your class, let's say on your product class, maybe you have, again, let's go to tags, but then you fetch items that where tag is not existing in the database or in your data, then you will have a null value when the SDK deserializes this to your class. Okay, so let me just put, a simple console write line with this one. And, first let's see if it's still building. Of course, if this is the first time that you are opening this code base, maybe you haven't restored the SDK yet. So the build will, of course, install the Cosmos DB SDK. And now that build, so I can use .NET Run, and we should be able to see the result. There we go. So very simple select statements. So another thing that I can show you is, comparing, we talked a lot about the point read versus the queries. So let me show you how that looks in practice. So let's say, if we go back to our data set here, let me just open that up. So we have all these items, and we want to get this particular item. For example, let's just pretend this is a human readable value. So we have the ID, we know the ID, and then for this particular container, we have category ID as the partition key. And remember, we both need the ID and the category ID or the partition key to be able to issue point read queries. Right. So in a normal SQL statement, if you're using SQL statements here, then let me just go back to VS Code. So typically, you can write your query as such. See here. So the very typical select statements, and then you have your filter where the ID is equals to that value, and the category is equals to the value of the category. And yeah, so this one is the category ID is your partition key, so it still work, and it will still try to find the node for that particular partition. And then if we run this query, we should be able to get the item as well. So what if I want to convert this particular operation or particular query into point read? So what we're going to do is just delete all this. We don't need that. And then the first thing we want to do is that, because we need the partition key, right? So we create a variable of type partition key. That's also part of the SDK. And then you pass the value of that partition key. In this case, it's the category ID. And then later on, we can write or call the method read item async. And as we have seen earlier, we pass the ID here with this value, and then we pass the partition key with a variable that you have just created here. So if we run this one, we should be able to get the same result here. And if you notice, when we did, it's the same result, but before you have a for each, because you're trying to, you expect with a query iterator that you're getting a collection. That's why you had a for each. But in this case, you just get a single item. So you just assign that to your object right away. So yeah, those are the two demos that I have.
That's really great. Loved it. We do have some best practice that I wanted to touch base on before we wrap today, because we are slowly but surely getting towards the end of our show today. And one of them is related to the thing that you have mentioned previously on null versus undefined, because a lot of people don't actually realize that there is a bit of an impact on whether you are defining or simply non-defining your properties, which are never going to be instantiated, right? And again, I want to emphasize that one of the biggest advantages of Azure Cosmos DB, and NoSQL in general for that matter, is that you have pretty much out of the box simple support for unstructured data. So if you have a Cosmos container that has items of varying structures or schemas, quote unquote, some items won't contain the same properties as others. And it is generally simpler and probably much more efficient to simply not define a property than it is to both define a property and assign a null value to it. So the advantages of this approach actually are all about savings on storage and ingestion costs and simplified queries. So a large number of null values in an item can be a signal that the data model can be further optimized, of course. But the advantages of not explicitly defining null value properties are going to be most obvious if you examine the RU charge of an item with a high number of null value properties. So for instance, consider the two items that you have here. Item 1 has 8 extra properties, field A, field B, all up to through field H, all of which have a null value. Item 2 has an undefined value for those properties and does not need to manually define them. And therefore, item 2 is smaller than item 1 and has fewer properties. And with the default indexing policy, writing item 2 actually costs up to 15% less RUs. And there's sometimes even a slight advantage for using null values when you're querying. An equality filter like where field A equals null, for instance, is typically slightly fewer RUs than using a system function such as where is defined field A, which we have covered previously. So I think it's very important to take this into account, because even though you get a lot of power and flexibility with Cosmos DB, also you should be careful with the responsibility that you have there. Also, when you think about the differences between null and undefined and mathematical expressions, for instance, there is always going to be an undefined return on any inputs that are non-number values. For instance, if you try to run a select one sum with string, that's going to return undefined. Or similarly, if you're trying to sum up one and null, or you're trying to sum up null and the string, it's always going to return undefined. And I'm mentioning this because in other languages, whether scripting languages or whether programming languages, the results might differ, right? So this is something that you have to be mindful about, especially on Cosmos DB. Now, I know we're slowly getting towards the end, and therefore I would rather say that we maybe skip the knowledge check for now, and just we only have a few minutes left, and maybe go through some questions that we have had from our audience. So I do see a question which actually came in quite a while ago, from Anish on YouTube. Is it always better to do a point read and then manipulate the data in memory than using SQL query? What would you say, Marilag?
Manipulate the data in memory than using a SQL query. I'm not sure I understand completely the question, because when you do a point read, you're essentially getting a single item. Correct.
Yeah, so I would assume that this probably has to relate to not knowing what you're querying for necessarily, or not having the right indexes. And then on the assumption that you have a large data set, you're retrieving the data and then maybe filtering some data out of it before you actually get to the data that you're looking at, versus doing a point read where you only have the identifier and the property. But I think some concepts must be properly explained, and these would supposedly or hopefully answer the question, which is, by default, Cosmos DB indexes everything. Whereas if you're thinking about the key value pair NoSQL technology and storage accounts, where you only have your partition key and your row key, which would be the equivalent of your identifier, you can't retrieve data on anything that is within the actual object, within the actual properties that you have persisted within the entities. Whereas in Cosmos DB, you can, right? You can write a query or say where attribute X equals Y or whatnot, right? But that would, again, if you don't know the partition, for instance, that would run on every single physical partition. It would run through the querying engine. It would incur multiple RUs. So hopefully this answers the question. I see another question along the same lines, actually. I think this was a duplicate question. I see another question, actually, which I honestly don't know the answer to. I will have to take this offline, but maybe you know, Marilag.
No,
Vernam on
actually, that's
YouTube.
your also.
Yeah, Vernam on
Oh,
YouTube
is that
actually wants
the
to know.
one on the role? Yeah, the one on role-based optimization and
Or cost-based
cost-based.
optimization. Yeah.
To be honest, I actually don't know, but from the top of my head, take this with a grain of salt. Isn't it something, maybe both?
As
That's
far as I know,
preferable.
yes, but
Yeah.
I'm not entirely sure on this one. I must be fair. Hopefully, Chris actually answered this one in the chat window. But Vernam, let's take this offline, and I'll be happy to chat with you. Okay, so unless we have any other questions, maybe shall we take one question from the knowledge check? Shall we do that?
Yeah, let's do that.
Let's try it. So you are tasked with writing the shortest possible SQL query to select all the items and include all the fields from your container. Which of these queries is both valid and would accomplish the task? So is it A, select from, B, select from P, or C, select asterisk from P? So what say you? Shall we start from the top? Select from?
I don't think so.
Why is that?
First of all, we don't have the property list. We don't know if we want to get all of the property or some of the properties. There's no way to tell. I mean, you can argue that this can be the default. Like if I don't pass an asterisk, then I can just say this is the default. But that's just like breaking the syntax. I don't think it's A.
Yeah, I also don't think that we can break the rules of the syntax. The reason for having a from there in the first place exists, and so does the reason for explicitly specifying the attributes that you're trying to retrieve or using an asterisk instead. You can't not say anything. So in all fairness, I would probably just simply go with C. Do you feel the same?
Of course.
Okay, we're locking in C. Let's see what the audience answers. Because, by the way, people, just make sure you head over to akmedia.ms/polls and you also answer this question. I'm going to quickly refresh my screen here. And it looks like, oh, yeah, we do have voters for C. So let's see. Is that correct? Yeah, sure enough. That was right, actually. Cool. We're gonna skip the other questions from our knowledge check because we're almost slowly but surely getting out of time here. Marilag, I don't know about you, but I've had a lot of fun actually covering today's topic, fundamental topic on running queries on Cosmos DB SQL API. We've learned a lot, haven't we?
Yeah, we did. And so fundamental, but still some interesting things.
So I do want people to know before we wrap up that if you want to learn more, there's more information about the topics that we have discussed in this module. And I do urge people to head over and go through at their own pace for the module on Microsoft Learn, and just make sure that they're going to get ready and to become certified and take the exam. And also make sure that you don't miss the next episode, which I believe you're moderating as well, Marilag, aren't you?
Yes, I am. Looking forward to see you all.
Great. It's going to be on authoring complex queries with the Azure Cosmos DB SQL API. Again, I don't know about you, but I have a lot of fun today, and I'm really looking forward for the next episode. And everyone, just make sure that you stay safe.
Thank you, everyone.